My name is Nur Atira binti Ahmad Faizal with number metric 280091. Today, I'm going to share with you guys how I solve mathematical problems by using Lagrange multiplier. So the question is, a factory produces two types of bolt, namely type KK and type LL. The total number of bolts to be produced is determined by the function FLK equal to 12L plus 20K minus L power of 2 minus 2K power of 2, where K is the number of KK bolts to be produced and LL is the number of LL bolts to be produced. The cost to produce 1 unit of KK bolt is Rm4 and for LL bolt is Rm8 per unit respectively. If the firm wants the total cost to produce these two types of bolts to be Rm88, find the greatest output possible subject to this budget constraint. From the question, I will take out information content that I can use to make a Lagrange function. So, I will write it like this. Equals, this one equals to 12L plus 20K minus L power of 2 minus 2K power of 2. This one I will make it as an objective function. So, another information that I get from the question is Rm4 ringgit is referred to the KK bolts. So that one, we will assume, I will write it to be like 4K. And then, in a question also say that Rm8 ringgit referred to LL bolts. So I will also write it like this. Then, in a question say, firms wants a total cost Rm88 ringgit. So from that information, I will write it. If we add these two items, it will be 4K plus 8L equal to 88. As I thought just now, 88 is because firms want a total cost 88 ringgit. So we want to make a constraint. So from that, we need to equal it to 0. So that it will be 4K plus 8L minus 88 equal to 0. How can it be like this? I change it to the left side. That's why it be a negative. So the constraint will be GL K equals to 4K plus 8L minus 88. So this is the information that we already got in the question, so that we can solve with another step. So just now, I already got two functions from that question. So these two functions, I will form it into a Lagrange function. So Lagrange function is FLK lambda equals to FLK plus lambda multiplier with GLK. So I will form it by using these two functions. FLK, just take this function back and put it here. 12L plus 20K minus L power of 2 minus 2K power of 2 plus with lambda. Take this GLK. We put this equation, okay? It's the same. Lambda multiplier 4K plus 8L minus 88. So we can see this is Lagrange functions. The next one, I will solve it to make it more easy to us to see or differentiate it. So I will write it 12L. We write this first back. 20 plus 20K minus L power of 2 minus 2K power of 2. Okay, this one. As we know that I need to multiply it. So it will be 4 lambda K plus x lambda L minus with 88 lambda. So here's the Lagrange functions. So I already write a Lagrange function that I get just now above here. So I will differentiate it to be FL, FK, and F lambda. So FL, we will get 12 minus 2L plus 8 lambda. For the FK, we will get 20 minus 4K plus 4 lambda. Sorry for the mistake, it's actually minus 4K plus 4 lambda. Okay, for the lambda, we will write it be 4K plus 8L minus 88. So all of above function, I will equal it to be 0. So from that, it will become 12 minus 2L plus 8 lambda equals to 0. 20 minus 4K plus 4 lambda equals to 0, and 4K plus 8 lambda minus 88 equal to 0. So here we will get 1 equation, 2 equation, and 3 equations. We get 3 equations from these functions. Next, one way to solve this system is to begin by solving each of the first 2 equations for lambda. So I will take equation 1 and equation 2. 12 minus 2L plus 88 lambda equal to 0, and it becomes, I'm going to make sure that the lambda will be a singular. It will become lambda negative 3 divide 2 plus 1 over 4L. So this is this one for the equation 1. For the second equation, it will be like this. 20 minus 4K plus 4 lambda equal to 0. It becomes 2 lambda equals to negative 5 plus K. So I'm done with this. So here's the equation that we're solving just now. By setting lambda equal to lambda, we're going to put it like this. Negative 3 over 2 plus 1 over 4L equals to negative 5 plus 4K. We solve this first. I'm going to solve this first, and it will be, it's up to us whether we want to make K or L be a singular. So I will choose L be a singular. So from that, I'm going to make L be singular at the left side. So the end of the solving, it will be negative 14 plus 4K. So here we get the value of L for a while. So we almost at the final step. So next step, I'm gonna share with you guys. I take the F lambda just now that we get, which is 4K plus 8L minus 88, and also the value L that we get just now, which is 14, negative 14 plus 4K. What I'm gonna do with these two equations, I will form L value into this value. So from that, we can know the value of K. For K, A, replace the L, this equation of L into this L. negative 4 plus 4k minus 88. So we will solve it. From there we can get 4k minus 112 plus 32k minus 88 equal to 0. Don't forget to equal to 0. So I'm gonna solve it. We proceed with the same step until we get the real number. 36. It will be 36k equal to 200, and we're gonna move this 36 divide the 200, and the 200 will be divided by 36 because we move it to the right side. The value of k we will get is 50 over 9. Just now I already get the value of L, and right now I'm going to find a value of k. How? It's still a same step just like before. So the k is, just how we get is 50 divided 9. This is the value of k. So this one we will substitute it into the k up here. It will be 4 multiplier 50 over 9 plus 8L minus 88. So here is just like we solve it, just like usual, we solve like before. So it will be 200 over 9 plus with 8L minus with 88 equal to 0. And then we move these two into the right side. So we will get 8L equal to 592 over 9. And then we make it L be a singular. The value of L we will get is 74 over 9. Just now I get the value of k and L, where k equals to 50 over 9 and L equals to 74 over 9. These two values we're gonna substitute it into an objective function, where f with 74 over 9, 50 over 9 equals to 12L plus 20k minus L power of 2 minus 2k power of 2. This is what I mean. We need to substitute it, okay? So I substitute 12 with the L value. L value 74 over 9 plus 20 with substitute k with the k value that we get just now over 9, this one, and then L 74 over 9 minus 74 over 9 power of 2 minus 2, 50 over 9 power of 2. So this, we solve this and we will get the answer is 724 over 9. So this value is the greatest output possible that firms can out. Finally, we are at the last step of this question answer. So we already got the k value is 50 over 9 and L value is 74 over 9, and the greatest output possible is the greatest output possible value is 724 over 9. So from this we can make a conclusion where the The greatest, therefore, the greatest output possible subject to the given budget constraint is subject to the given budget constraint is 700 to 24/9, where the number of KK box and LL box are 50/9 and 74/9 respectively. So here is the last of our answer in this question. It also, we can say that the value of K, we can say 6, approximately 6. For L, approximately 8. It also can be like this. So I prefer to write it like this than the singular. So here's the end of the answer for this question. Thank you for watching.